Okay, hello and welcome to the fourth lesson of this course, where I'll be teaching something essential to programming and especially scientific programming, which is control flow. This lesson will be comprised of 4 segments, and I definitely encourage you to take your time and rewind if some part is confusing and you want to revisit it. And as usual, you can access the PDF version of these slides from Canvas. And for this lesson, there's also an accompanying Colab notebook with the code that I'm going to show. And I'd encourage you to run and tinker with that while watching this. If you need clarification on anything, you can always ask a question on Piazza, and we will try to get back to you quickly. So in this first segment, we'll be looking at what's called a for loop. But first, what are loops and why are they useful in programming? Let me give you an example. So sometimes you might want to do something repetitive, like printing every value of this list called temperatures on its own line. So here we write 6 print statements in a row to print each temperature. You might be thinking, well, okay, that's not so bad, but what if this list had 100 values in it? Well, now it gets pretty ridiculous. And it also gets really easy to make errors. For instance, I made one error here. Can you spot it? Oh, here it is. I wrote temperature instead of temperatures. But I don't blame you if that was hard to find. As you can see, clearly this approach is messy and less than ideal. And this is exactly why we use loops. Loops simply are an efficient way of repeating an action multiple times. So here's the basic structure of what's known as a for loop in Python. For some variable in what's known as an iterable, colon, do something, which we'll call an action. And let's break this down a little bit more. So this first line starts with the declaration for, and then this variable should have a unique name that you haven't used yet in your code. And then the for loop will be assigning that variable a new value each time it loops. Next, we have the word in, and then this thing called an iterable, which in Python is any collection of objects that you can iterate or cycle or repeat over. And it's this iterable that will give the variable its values. I'll talk about iterables more in the next slide, but the next element you need is this colon, which is essential. Then you hit return to start a new line, and you absolutely must indent, which you can do using the tab on your keyboard or by typing 2 spaces. And at that point, you can tell Python to do the action that you want to repeat, which might be some print statements, variable assignments, calculations, etc. And everything that's indented below this for statement will become part of the loop. Okay, so what are some iterables that you can use in a for loop? Well, these should be pretty familiar. A list is a common iterable because it has elements that a loop can iterate over. 4, 3, 2, 1, for instance. A tuple is also an iterable. In parentheses, ph, Puget Sound, 7.8. Now, string is actually an iterable too, so here a loop would iterate over its characters, HELLO, for instance. And Katie introduced you to the range function in lesson 3, which, if you remember, it takes 3 arguments: the start value, the stop value, and the step value. So for instance, range 072 is basically the same thing as a list that says 0, 2, 4, 6, because it counts starting from 0 and it stops before 7 using an increment of 2. And finally, there are these last 2 iterables, the enumerate and the zip functions, which we haven't learned yet, but we'll get to later in this lesson. So these are all collections of objects that you can use to iterate over in a loop. And of course, you can refer to iterables in a loop by assigning them to variables beforehand, like for instance, countdown for the list, ph data for the tuple, hello string for the string, or even numbers for the range object. And what does this look like? So starting with the one on the left, for item in the list, 4321, colon, new line, indent, print that item. So here we're calling this required variable item, and the for loop will iterate or cycle over the 4 values in the list, saving each value into the variable item, one by one. And at each iteration, it will print that variable called item. So it enters the loop, and it prints 4. Then it loops again, and item becomes 3, so it prints 3. Then item becomes 2, so it prints 2, and so on. And then 1. and it's done. So the example on the right does exactly the same thing, but here you've saved the list as a variable called countdown beforehand. So the loop goes for item and countdown, print that item. Same result, 4, 3, 2, 1, done. So here's another example of a for loop iterating over the tuple that I showed earlier. For every value in the tuple ph, Puget Sound 7.8, colon, new line, indent, print that value. And here it loops 3 times and it prints ph, Puget Sound 7.8. And again, same thing on the right, you've saved that tuple as a variable called ph data. And so you can iterate over that variable with the same results. And another example. So here we're using a for loop to iterate over the characters in a string. We've called the variable character. And at each iteration of the loop, character gets a new value. First H, then E, then L, L, O. And it loops 5 times because hello has a length of 5. Same thing on the right, except we've taken advantage of assigning the string to a variable called hello string beforehand. And we can use that variable as our iterable in the for loop. And one last example. So in this case, the iterable is a range object, which we've given arguments of a starting value of 0, stop value 7, increment or spacing of 2, which again is the same as saying 0, 2, 4, 6. So that's what it prints. And on the right, same thing, except here we've saved that range object as the variable even numbers. The for loop iterates over it with the same results. So how can loops actually be useful besides just printing stuff? Well, one example is calculating the sum of a list of numbers. So here we've assigned the list 5, 6, 7, 8 to the variable numbers. And we've also created a variable called sum, which we're going to use to keep track of the sum as we go. So we initialize it as 0. Then we write the for loop for value in numbers, set sum to the quantity sum plus value. So on the first iteration of the loop, sum starts at 0, value starts at 5, and then sum equals 0 plus 5. Then on the next iteration, sum is 5, value is now 6, and we say sum now equals 5 plus 6. So now sum is 11, and so on. This loop will cycle 4 times since numbers has a length of 4. And at the end, outside the loop, we're printing sum to see the result, and we find that it's equal to 26. So what's another way that we could have written this? Oops. Do you see the difference here? So here we've used an assignment operator, which Katie discussed in lesson 2, saying sum plus equals value. And if you remember, that's the same thing as saying sum equals sum plus value, but it's just a bit more compact and more efficient. And here is a third way to write this. And this one is really important to understand because you'll be seeing and using this frequently. So in the for loop, we're saying for index in range of the length of numbers. And recall that the len function returns the length of a list, tuple, or string, and the length here is 4, so range of 4 is the same as a list that counts from 0, 1, 2, 3. So for each item in 0, 1, 2, 3, which will be called index, sum plus equals the index value of numbers. So on the first iteration, index is 0, and the 0th value in numbers is 5. On the second cycle, index is 1, and indexing into numbers using 1 gives 6. On the third cycle, index is 2, and so you're adding 7 to sum, etc. Okay, same result. And again, remember this type of format. It's really common in what we'll be doing this quarter. And yeah, that's it for the segment. So see you in a bit with more about loops.